Hi, welcome to my video on proving a quadrilateral is a parallelogram. And this is extra practice number 1. The more practice you can have in proving a quadrilateral is a parallelogram, the better you become. So let's do number 1. Again, pause the video and work these out beforehand if you wish to see if you work these through. So we have a diagram. MA is parallel to TH, so MA is parallel to TH. We have angle 1 equals angle 2 given, and we want to prove that MATH is a parallelogram. Well, we have one pair of sides parallel. If we can get another pair of sides parallel, which is these two, then we'll have a parallelogram. Or we can get the same pair, MAHT, parallel and equal. So we already have these given as parallel. 1 equals 2, alternate interior. Therefore we can have MH equals AT. Because we have two pairs of parallel sides, we have a parallelogram. So here we go. We're given that MA is parallel to TH. Given. And we're told that angle 1 is equal to angle 2. That's also a given. And because 1 equals 2, that means that MH is parallel to AT. And that's the converse of the PLT, alternate interior angles equal, which means if these are alternate interior angles equal because they're on opposite sides of this transversal HA forming the Z. That means these lines are parallel, and because we have two pairs of sides parallel to each other, that means MATH is a parallelogram. Either, and you can also say that it's the definition of a parallelogram, which means opposite sides are parallel. We have a parallelogram, or we can say two pairs of opposite sides equal. We have a parallelogram. Let's look at number 2. We got many numbers here, so let's see how we're going to fit it together. Angle 4 equals angle 7. Angle 4 equals angle 7. Angle 1 equals angle 2. So I mark this with 2 strokes. Mark the first pair, 4 and 7, with 1 stroke. And MH is parallel to AT. We mark that. And we got to prove that PATF is a parallelogram. So we got many ways to prove a parallelogram, but which one are we going to use here? Well, we got 4 equals 7. So these are linear pairs. So that means I can get 5 equals 6. That's opposite angles equal in this PATF. I have these two lines parallel, so I can have 2 equals 3 because of corresponding angles on the same side of transversal. So if 2 is equal to 3 corresponding, 1 is equal to 2 given, that means I can have 1 equals 3 by transitive. So I got 5 equals 6, 1 equals 3. They're the opposite angles in the parallelogram equal, so I have a parallelogram. So that's my plan. So angle 4 equals angle 6 given. That means I have angle 4 and angle 5 are a linear pair. And angle 6 and angle 7 are also a linear pair. That's the definition of a linear pair that we went over. We went over that in the congruent triangle chapter. Linear pairs, two angles that are adjacent forming a straight angle. So out of that we have angle 4 is supplementary to angle 5, and we have angle 6 is supplementary to angle 7, and that's because we have a straight angle. And as a result, 4 equals 6. That means that angle 5 is equal to angle 6 because of supplement angle theorem. SAT, supplement angle theorem. Supplements of congruent angles are congruent. Now we have angle 1 equals angle 2 given. So we have the parallel lines, so it's MH is parallel to AT, and that's also a given. Again, we could put all the givens in the first statement. Check with your teacher. Because MH is parallel to AT, that means angle 2 is equal to angle 3. And that's PLT, corresponding angles equal. COR, short for corresponding angles equal. And because we have 1 equals 2, and because 2 is equal to 3, that means angle 1 is equal to angle 3, and that's substitution. The substitution is dealing with steps 5 and 7. Step 5 and 7. And now we have 5 equals 6, 1 equals 3. That means that PATF is a parallelogram because we have two pairs of opposite angles equal. Because we have 2 pairs of opposite angles equal, then we have a parallelogram. Okay, let's try number 3. Don't forget to pause the video and see if you can work it out beforehand, because the more you can do on your own and put it together, the better you're going to be. Here we go. Got this diagram. We're given that EG is parallel to JH. So EG is parallel to JH. Given. We have OF equals IO. Given. And we got to prove that EGHJ is a parallelogram. EG. We already have these two sides, EG and JH, parallel. So I can either get GH parallel to EJ and get 2 pairs of sides parallel, or I can get this side equal, GH equal to JH, and have the 1 pair equal and parallel. So why do I have OF equals OH? Well, that's the only segment that's equal here. Besides, we got, reflexive in the big triangles. But if you deal with the big triangles, we don't have any, this is a side, and we can't get the big triangles. We can't get congruent segments. We can get this triangle, EGJ and HJG. We can get those congruent, but we still can't get, or can we? If we had, let's see, that triangle there, and no, we can't get them. They're crisscrossed. So let's go with FO equals IO, given, and let's pick up that EG is parallel. Why did it give me EG parallel to HJ? Well, parallel lines will give you equal angles. So what happens is that angle 3 equals angle 4. Angle 1 is equal to angle 2. So angle 1 is equal to angle 2 because of VOAT, vertically opposite angles. Angle 3 is equal to angle 4, and that's the PLT, alternate interior angles equal. And notice now that we have, based on that, we have this triangle FOG is congruent to IOJ, and that's by angle, side congruency. So that gives us FG equal to IJ CPCTC, and we got these two equal. Now I can do the same thing in triangle EFO and IOH. We do exactly the same steps to pick up that EF is equal to IH. So we can go with 5 and 6. Angle 5 equals angle 6 by VOAT. EH and FI are cutting each other, so the vertically opposite angles are equal. And we have the parallel lines here, so that means we can have angle 7 and 8 are equal. Angle 7 is equal to angle 8, and it's the PLT, alternate interior angles equal. Notice I went with the two different pairs, these two here and these two, because I wanted to do the triangle separate. So I have triangle FOE. FOE is congruent to IOH. And the same reason is angle, side, AAS, and that gives us EF equal to IH CPCTC, and we have all that. Now we have, if you take these two, you take EF and add on FG, and you take 8IH or HI, don't make any difference, whatever one you want. These two are equal here, so you can take, we got EF, this one, so we'll take IH, add on JI, and that's addition property. I'm adding this segment equals this one, this segment equals this one. I'm adding these two together and these two together. That's the addition property of equality. And as a result, let's see, we have that EG is equal to EF plus FJ, and JH is equal to JI plus IH. And that's the segment addition, property, PROP, and hence we have EG equals JH by transitive. So we have EF, FG right here. We have JI, IH right here. And since these are equal to, since these two are equal to these two and they're right here, that means EG equals JH by transitive. And that's transitive in, I'm going to mark this 11 and 12. So that makes, we have EG equal to JH and EG parallel to JH. So we have EG HJ parallelogram, because we have one, mark that, one pair of opposite sides are equal and parallel. One pair. Again, that EG is parallel to HJ and EG is equal to HJ, so that's the pair that's equal and parallel, so we have a parallelogram. You can see why I only do a few proofs on the quadrilaterals, because the proofs takes a little bit longer to do, and that's why I'm doing 3, and I got another video coming right after this one with 3 more examples of proofs on proving quadrilaterals, parallelograms. And if you like my video, click on the like button, subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.